Good morning, everybody. Today I am going to be talking about chair forms and kind of giving a breakdown of drawing and doing some other stuff involved with them. So we're really just going to kind of take it slow and make sure you guys really understand how these work. I'm actually going to start off a little bit of a drawing tutorial. So for drawing chairs, you want to imagine that you have, I'm going to draw in two sets of parallel lines. Two rows here. And you're going to draw a set of parallel lines that are going up and then in another set of rows a set of parallel lines that are going down. From here, we need to make, let's start on the one on the left. We're going to make a point that's going to be outside of our parallel lines. It's going to be above this guy. So we're going to make a point right here. On the other side, we're going to make a point that's below this. Like so. And then we will connect the lines and we make a chair. Same thing on the other one, point below, point above, connect the lines, and that's going to give us our other chair. So notice that they're mirror images of each other that could be folded in on top. All right, let's do it again without the dotted lines. So starting by drawing two sets of parallel lines, you'll notice that you're not drawing this. You need them to line up this way as opposed to having actual parallel lines which would line up like this. Make a point, make a point, connect them. The other one, we draw our other set of parallel lines, so sloping downward. Again, you can imagine those parallel lines. Make a point above, a point below, and connect. All right, I'm going to start by focusing on just axial positions. So all of your axial positions are going to either look like this, or like this. We're going to make either upside down Ys or regular Ys. So if I take a look here, I'm filling it in green. This is like the bottom half of this, which means we're going to get an axial position to complete our upside down Y. That would go here. Same thing below it. This would get us another axial position. On the bottom, we've got an upside down, part of a Y here, part of a Y here. That would represent this and this. These two can come together. It's missing the bottom part of its Y, like so. Do the same thing over here. The ones in the ends are not as pretty looking, but you can kind of see how this makes kind of that Y component pointing downward. And this one is similar as an upward pointing one. It's just a little bit less clean. And that's going to be all of our axials. For this left chair. For right chair, following the same concept. And you could kind of say that they're making a V towards where you should go. So this is kind of one V that's pointing upward. So its axial should point upward. There's a V here pointing up. It needs an axial up. This one's kind of making a V going down. Same thing with the one next to it. You can see a V going up here. And then one going down over here. So these are the 6 axial positions. Well, I guess the 12 total for these two molecules here. Our equatorial are always going to be going in the opposite direction. And they're going to be going outward. So this one I'm going to highlight here is going upward. You can see it's pointing straight up. So equatorial is going to be going down, but also out. It's going to look like this. And by out, I mean, if you think of there being an imaginary middle point to this, they're going to be pointing away from that middle point. So this next one I'm highlighting here in blue, it's pointing downward, which means equatorial should be pointing up and away from their middle line, like so. Same thing here. This one's pointing down, which means their equatorial should be pointing up and away. Looking on the other side, this one here is pointing upward. So we need one that's pointing down and away from center. Pointing upward, so we need one going down and away from center. This one here is pointing down, so we need one that goes up and away. I'm going to draw this guy in green, make it a little. So same thing over here. I'm drawing blue. So this point here is going up, which means this one is going down and away from center. This one's going down. It's going to be going up and away. This one here is going up, so it should be going down and away. Same thing for these. We have an up, so down and away, down, like so. Are there any questions up to this point? Okay. I'm going to erase this. I'm going to redraw them. Let's talk about what positions are where. if I'm looking at these two molecules, and I can kind of, if I wanted to try to redraw them as being actually perfectly parallel lines, I'm just rotating it a tiny bit to make it a little bit more in plane. It's easy to see that this position here is going to be the same thing as this position down here. 2 is the beginning of a parallel line. 3 is the end. 4 is where you're starting to flip sides. 5 would be this position. And 6 would be here. Does that make sense, everybody? Anybody awake?
Yeah, that makes sense.
Okay. So we're going to take this and we're just going to put it back into our normal molecule. So 1 is here. That makes 1 here. 2, 3, 4, 5, 6. 2, 3, 4, 5, and 6 here. This is going to be really important when we start drawing these. So let's do a really simple chair structure. Okay. Everything's going to have 2 chairs. So you might as well just start by drawing both of them. So the way I would approach these is pick something to be carbon 1. Doesn't necessarily like have to be based on naming convention or anything, but it's going to help you if you're consistent that way. So if I say this is 1, 2, 3, 4, 5, 6 here, if I make this carbon 1, we're going to follow around clockwise just like we did up there. 2, 3, 4, 5, and 6. Like we just talked about, this point equates to this point here. So now 2, 3, 4, 5, and 6 would be these positions. If you look at your molecule, we have stuff on 1 and 3. We have a methyl group and a bromine. Methyl group on 1, bromine on 3. So we don't really care about 2, 4, 5, or 6. So we can kind of get rid of those. Oh. And just focus on these 2 positions. So I usually tell people just start by drawing in the axials and the equatorials, regardless of what you have. So if I look at position 1 on the left, it's making the, nope, that's the wrong thing. There we go. It's making this kind of a V here, which means its axial is going to be pointing upward. If the axial is pointing up, our equatorial is down and to the left. For 3, we're making this V here. It's going to point up. For axial or equatorial is down to the right. Same thing for the other molecule. 1 is going to point down. Equatorial is going to point up and to the left. 3 is going to point down. Equatorial is going to be pointing up and to the right. Also, generally speaking, the axials and the equatorial should always flip between your two chairs. So if this is going up in your one chair, it should be going down in your other one. If you end up having the same thing, that means you messed up somewhere. Okay. So as a general rule for these, if you have a wedge, this is going to equal your up position. You have a dash, this is down. That doesn't mean that it's axial or equatorial. It literally means that if I look at, so let's take carbon 1, for example, here. If I had to compare these two positions, like just looking at their axial and equatorial options, I would say that this is up and this one's pointing downward. If I look at the other carbon 1, I would say that this is going up and this one's going down. So I'll actually write CH3 over here. In order to fill these in, we have a wedge, which means it's up. So this CH3 would go here. RH would go in this position. Looking at our other chair, up should be the CH3, down should be the H. All right, same thing with the next position. We've got a BR. It is a wedge, which means it should be in our up position. So looking at chair 1, of the two positions, this one points up, this H points down. Looking at another one, this equatorial ports up, this axial points down. For determining stability, you want to favor having more equatorial positions. So we don't really care about the H's, we only care about the substituents. This has two positions that are axial versus this one, which has two positions that are equatorial. This one would be more stable. Any questions so far? Okay, I'm going to give you guys a molecule, have you draw it, and then we'll go through it together. So I'm going to give you guys about, I don't know, 3 minutes to go through and draw this, and then we will go through it together as a class. so let's draw. Our two chairs. I like to make this position 1. Same thing over here. I'm going to assign this to be position 1. We don't really care about 4, 5, and 6. They don't have anything on them. There we go. Okay. So I'm going to start by just drawing in our axial positions. This one should point up. This one should point down. This one should point up, down, up, down here. Our equatorial should be the opposite direction going out. So this goes out. This, man, that's a little steep. I'm going to redraw this one. There it looks a little better. I don't love this one. There we go. All right, so some equatorials on our other chair. Keep that position 1 written in there. All right, so looking at what we have, just going to write CH3 up here. We have a CH3 on a wedge. So looking at our carbon 1 on the left of the two positions, this one is the one that looks like it's going upward because we have a wedge and wedge equals up, which would make this equatorial one the one that's going down. Looking at our other chair of the two positions we have drawn, this equatorial is the one that's pointing up versus this H, which is pointing downward. Looking at carbon 2, we have a Cl on a wedge, so a Cl that should be going downward. Of our two positions on carbon 2, this one is the one that's going down, putting our H here. Looking at our other chair, this would be down, this would be up. Lastly, we have an iodine that is on a wedge. Wedge should be up. So I'm going to draw an iodine in our up of these two, H in the down. This one would be up. This one here would be down. Taking a look at stability. Axial, 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 equatorial, equatorial, equatorial. So this one here should be our most stable. Any questions on this one before I give you guys a few more to work through? Okay, I'm going to draw up 2 more of these, maybe 3 more of them, have you guys work through them, and then we will take today's quiz. All right, I'm gonna meet back with you guys around 11:48. I'll start kind of drawing in some just like chairs and some other like little clues. If you guys get stuck, feel free to kind of look up and see where I'm at and see if that helps. All right, so I have this kind of drawn out. I basically kept carbon 1 the same for everything. And in my mind, that works a lot better. You never really confuse yourself. So if we start with this first one, for carbon 1, I have the actuals and the equatorials already drawn out. We have a wedge, CH3, which means our CH3 needs to be in the up position of the two positions. The axial one is up relative to this equatorial, which is down. Looking at our other chair, this equatorial would be considered up, and this axial would be considered down. Carbon 3, we've got a dash CH3, so a down CH3. Of the two positions, this one should be down, this one should be up. Same thing on our other molecule, down should be, in this case, axial, and H should be equatorial. Looking at our last one, we've got another wedge CH3, so another upward facing CH3 on position 5. If I draw in a 3 here, CH3 here, and H here, the other one, CH3, would be in this position versus this one here. In terms of stability, I've got 1 equatorial versus 2. And we got 2 axials versus 1. So this one on the left has less equatorials, has more equatorials, less axials. So this one should be our more stable. Taking a look at, well, these are kind of close to each other. These a little shorter. Okay. Taking a look at position 1, we've got a CH3. It's going up because it's on a wedge. Putting H here. Other position. Oh man. We're out of space down the bottom for an H. Position 2, we've got an I down and a dash, so it should be going down. Position 4, we have another CH3. It's on a wedge, so it should be going up. And then position 6, we have a Cl. It's on a dash, so it should be going down. Circling all our equatorials. So we have 1 here versus 3. Looking at our axials, we have 3 versus 1. The bottom one has more equatorials. This is our more stable. And some of the times you do have to look at what substituents they are, but for these, they should be pretty straightforward. I mean, you've got the iodine, the chlorine, and a CH3 that are all equatorial. All right, let's take a look at the last one. Position 2, we have a wedge CH3, so that one should be going up. Position 2. Position 3 is a fluorine wedge, so it should be going up. And then position 5 is a fluorine wedge again, so it should also be going up. Taking a look at our equatorials versus axials, we've got 1 equatorial versus these 2 fluorines on equatorials. This one has 2 axials. This one only has 1, so our bottom one should be our more stable. Don't know why it keeps being the second one. Okay, any questions on these chair structures? Technically, you don't need to draw on the H's, but I think it's easier to draw both of them.
if we like numbered the third one differently, so I like started with one as the methyl group, it's still correct, right?
Yeah, it's still correct. It's just going to look a little bit different. You should
Potentially.
still kind of get the same. Like you should have one of them that has 3 equatorials and one of them that has 3 axials. It's just going to look a little different.
Okay.
All right. So turn on your webcams, pull out a piece of paper. Let's see. Today's quiz is a Newman projection diagram. So the molecule is shown up top, and then fill in the 4 Newman projections and label the energies. Sorry, 6 Newman projections, label the energies.
Do you still want us submitting it into quiz 8? Because it says that quiz 8 was due yesterday.
Oh, yep, still do that. Sorry about that.
Okay, that's okay. Thank
I'll
you.
fix it. Yep.